moving towards next question, question number 78. The simplified form of root 6 plus root 10 minus 21 root 121 minus root 35 times root 6 minus root 10 plus 21 root minus 35. What is the simplified form of this one? If we are going to take orthodox root, keep on multiplying 4 the 16 terms we have to simplify. Look at this, root under root 6 and root 35. They have the same symbol in both the brackets. Root 6 and root 35. They have both same symbols in both brackets. Positive root 6, positive root 6, negative 35, negative 35. That is the key that is going to lead us somewhere rational, somewhere at a good platform. In a simple fashion, we can negotiate this question. So I can write this as writing root 6 and root 35 first, then the remaining minus root 21 and plus 20 plus root 10. That is our first bracket. Second bracket is again root 6 minus root 35 plus root 21 minus root 10. Now look at this. These two parts, this part is identical in both brackets. Symbol wise magnitude, they are identical, they are identical, they are identical, they are identical. If we take minus common from this, these remaining two terms have become identical symbol wise as well. Let's see, root 6 negative root 35, taking minus common, we are going to have root 21 negative root 10. It's our first bracket. I have taken just a negative common from this. I have taken negative symbol common from this. It will become positive root 21 and minus 10. Similarly, writing this one, root 6 negative root 35 plus 21 root 10. Now demarcate brackets here. Now look at this. This portion is identical as x, it's y, it's x, it's y. Here it is positive, here it is negative. Look at this. X minus y, x plus y. The lone difference between these two brackets is now of symbol. A difference of two square substitution. A minus b, x minus y, x plus y. X minus y, x plus y. It is going to be equal to x square minus y square. X square minus y square. In our case, x is root 6 negative root 35 whole square minus root 21 negative root 10 whole square. This is our x minus y, x plus y. That is situation of difference between two squares, x square minus y square. Our x is this, our y is this. Open this up. A square minus twice first into second plus square of second. Here in first two brackets the first term root 6 and the remaining two brackets root 35. Okay, minus applying the whole square situation here. Root 21 square minus 2 times root 21 times root 10 plus root 10 square. Root 10 square. Root 10 square. Now square and root cancel. It is 6 minus 2. 6 times 35. It is 210 in the root. Square and root cancel. It is 35. Next bracket. Square and root cancel. We have only 21. We have only 21 minus twice 2 times 21 times 10. 21 times 10 is 210 and square of 10, square of root 10 is only 10. Now multiplying this symbol with complete bracket. Open this up, it will become negative, positive and negative. We have 6 negative 2 root 210 in the square root plus 35 minus 21 minus plus 2 times root 210 minus 10. Positive negative cancel out. 6 and 35 both are positive. 41 negative 21 negative 10, it will become 31. So our answer is 10. Answer is 10. Without taking much troubles, we have settled down this equation. Root 635 or root 635, they have same symbol in both brackets and they have different symbols. I have taken root 6 root 35 first, minus 21 root 21 plus root 10, and here it is positive root 21 minus 10. Taking minus common is a magical step in that case, magical step. Now the remaining two brackets, after taking minus common, it will become root 21 minus root 10. These two remaining part is also become identical after taking minus common. Now we have the only difference here, it is negative, it is positive. It's our x minus y, it's our x plus y. That is situation of difference of 2 square, x square minus y square. Just merely plugging in the values of x, that is root 6 minus 35, and y is root 21 minus root 10 whole square. Open this up, taking care of this symbol. This symbol will affect the all the remaining upcoming terms here. It is. This negative, change the symbol of all these three terms and simply calculating 635 positive 41 minus 21 minus 10 is minus 31. 41 minus 31, 10 is our answer. Moving towards next question, question number 79, it reads as, an employer pays rupees 20 for each day a worker works and forfeits rupees 3 for each day he is idle. At the end of 60 days, a worker gets rupees 280. For how many days did the worker remain idle? An employer pays rupees 20 for each day a worker works. 20 days for each, 20 rupees for each day a worker works. If he is not worked, then he has to pay. Forfeits rupees 3 for each day when the worker is not working. Worker is idle. At the end of 60 days, a worker gets rupees 280. For how many days did the worker remain idle? Total number of days that we have given, it's 60. Means W stands for worker works, I for idle not working. Total days are 60. Equation number 1. It is a working, W stands for working day and I for idle. Working days plus idle days, lump sum equal to 60. We have given total 60 days. Whenever he is going to work, he earns 20 rupees. 20 rupees. And if he is not working, then he has to pay. He has to pay negative. 3 times idle, and he obtained total lump sum of 280. Minus shows that 3 rupees forfeits for each idle day. For each not working day, he has to pay 3 rupees. Simplify. We are interested in solving this equation. If you multiply this one with 3, then we can easily manage the value of W and I simply. Solving this, our first equation is W plus I, that's 60 days. Positive, negative, it's negative. 3 times I is equal to 280. Multiplying equation 1 with 3, we have 3W, 3I is equal to 180. We are multiplying this equation with 3 in order to get rid of this I. I for idle days, W for working days. Add up 20W plus 3W, it will become 23W. Adding them up 0, 8, 8, 16, 1 carry, it's 460. Solving for W, we have 460 divided by 23. Applying table 2 times, 0 same. So, the working days are 20. We are asked to find for how many days did the worker remain idle. He is not working. Total is 60. Putting value of W here, 20 plus I is equal to 60. This implies that I is 60 minus 20, 40 days. He remained idle for 40 days and he worked for 20 days. Let's verify by utilizing the rates he has to obtain or to give. They are total 60 days. He worked for 20 days. 20 rupees for each day. He worked for 20 days. He obtained 400. While he remained idle for 40 days. 40 days. 40 hours. He has to pay 3 rupees when he is idle. 3 for the 120. Difference of 400 and 120 is definitely 280. That is the verification step in our case. An employer pays rupees 20 for each day a worker works and forfeits rupees 3 for each day he is idle. At the end of 60 days, a worker gets rupees 240 for how many days did the worker remain idle. Total days are 60, whether working or idle, 60. Whenever he is working, he is obtaining 20 rupees. Whenever he is not working, he has to pay 3 rupees. 3 rupees minus 3. Total lump sum after 60 days, he obtained 280. Simply these two equations solving. We have multiplied equation 1 with 3 and adding them up and so on, or you can apply any other method, substitution method, whatever suits you. Moving towards next question, we have, moving towards question number 80, the average marks obtained by 120 candidates in a certain examination is 35. The average of marks obtained by 120 candidates in a certain examination is 35. If the average marks of the passed candidates is 39 and that of the failed candidates is 15, what is the number of the candidates who passed the examination? How many candidates we have in total? 120. Their lump sum average including failures and passed candidates is 35. However, the average of only passed students is 39 and the average of failed students is 15. Individually, their averages are 39 and 15, passing and failing. Overall average 35. We are interested what is the number of the candidates who passed the examination. Equation number 1, whether it is passing candidate or failure, their figure is 120. Passed students as well as failed, their lump sum total is 120. It is given to us 120 candidates. And second, average for passed candidates, their average is 39, while failure having average 15 divided by total number of students, that's 120, and their average is 35. There are two categories of students, passing and failure candidates. Their total is 120. It is given to us. The average of the passing students is 39, while the average number of failure students is 15. And their lump sum average, collective average, including passing and failures, passers and failures is 35. If I move 120 here from division to multiplication, there is another equation. Solving these two equations simultaneously, we arrive at our required result. It will become 39p plus 15f is equal to 35 times 120. That's our 39p plus 15f. That's our, I think, 4200. It's our equation number 2. Now, there is the case. If I multiply this quantity with 15 in order to get rid of failure, that's my equation number. First, let me multiply this one with 15. It will become 15p plus 15f, 120 multiplied by 15, 12 multiplied by 5, 2 5 the 10, 1 carry 1 5 the 5, it will become 6. Again 2 and there is one 1800. Subtracting we have 39 minus 15p, it's our 24p. 4200 minus 1800, that's our 2400. Solving for p, we have 2400 divided by 24. Apply table one time, same. So the number of passing candidates is 120. Number of the candidates who secured 39 marks as average and passed, they are 100, while the number of the failure student is obviously 20. Because the sum of passers and failures is 120. Plug in the value of passer here, 100 plus f plus 20. Solving for f, we have failure number of candidates is only 20. However, we are asked to find the number of the students who passed. The number of the students passed, 100 students passed the examination in that case. It's my tiny effort, you guys, to explain you some quantitative type of questions. It's all by itself. Next.